Assalamualaikum and selamat sejahtera. My name is Nafika Binti Azlan. Today I would like to present my final year project proposal. My title is the removal of dye pollutant from textile wastewater solution using nanocellulose filter paper made from NEOLAMARCKIA CADAMBA tree. Water is essential to human, plant and animal survival. It is crystal clear that the earth cannot survive without water, as it's one of the most essential natural resources for all living things and one of the basic for daily needs routine. As the foundation of life, societies and economies, it carries multiple values, benefits and functions. However, nowadays, the elevation of industrial activities, uncontrolled usage of chemical in domestic area and urbanization process keep happening, and it can lead to serious pollution, and because of that, it needs to minimize the safe water resource throughout the world. There are so many of industrial activities that contribute to this pollution are called as dye chemical, such as food processing, textile, leather, dyeing and cosmetic. This issue needs to be taken seriously as it will impact human health as well as the environment if the dye chemical that have been discharged were not carefully treated, especially when it is discharged to the rivers or streams that happens to be Malaysia's #1 water resource. Wastewater from dye house can have a strong impact on the aquatic environment. Therefore, the effluent must be treated before discharge from the industry. Different treatment methodologies have been employed to treat textile wastewater, such as reverse osmosis, ultrafiltration, nanofiltration, membrane bioreactor and adsorption method. Reverse osmosis is a water purification process that uses a partially permeable membrane to separate ions, unwanted molecules and large particles. Reverse osmosis is growing in popularity when it comes to managing and treating wastewater, especially in industrial process. Ultrafiltration is a water purification process in which water is focused through a semi-permeable membrane. Even though UF membrane have been successfully applied in many industries, they have not been as widely accepted by the textile industry because they do not remove low molecular weight dyes. Nanofiltration is a pressure driver membrane process that lies between ultrafiltration and reverse osmosis in terms of its ability to reject molecular on ionic species. NF membranes, unlike reverse osmosis membranes, can operate at lower pressure and provide selective solute rejection based on both site and charge. Membrane bioreactor (MBR) is a hybrid process which has two independent treatment process, which are biological treatment and membrane filtration. Membrane bioreactor (MBR) technology has been used widely for various industrial wastewater treatment due to its distinct advantage over conventional bioreactor. Adsorption is a mass transfer process whereby elements gather at the interface of two similar or different phases, for instance, gas-liquid, gas-solid, liquid-liquid and liquid-solid. Adsorption technology is an equilibrium separation process that has high potential in wastewater treatment application. Cellulose is the most abundant polymer in the world, which can be found in wood, hemp, cotton, cereal straws and other plant-based materials. Cellulose is mainly used to produce paper board and paper. Cellulose for industrial use is mainly obtained from wood, pulp and cotton. Cellulose nanofiber are constructed from alternating crystalline and amorphous domains of elementary nanofiber, which represent in stretched bundles aggregate formation. CNFs can be extracted from plants, microorganisms and animals. The extraction of CNFs from plants can be divided into two categories, which are softwood and hardwood source. So, for this final year project proposal, I will use NEOLAMARCKIA CADAMBA as a nanocellulose filter paper to remove dye wastewater. NEOLAMARCKIA CADAMBA is a member of the NEOLAMARCKIA tribe in the Rubiaceae family and is commonly known as Kelempayan or Laran in Malaysia. It is commonly known as Kadam in India and has been widely used in Indian traditional medicinal formulation. For the information, NEOLAMARCKIA CADAMBA has scent orange flower present in dense globe-shaped cluster which are used in the preparation of perfume and also ornamental properties plant used for timber and paper making. Many communities and tribes across India use its bark, leaf and flower against various ailments such as sore throat, cough, fever, infections and inflammation. There are so many uses of NEOLAMARCKIA CADAMBA. For the problem statement, it is not that the major source of textile industry wastewater pollution are concentrated in Peninsular Malaysia, with Johor State having the highest number of water pollution source, 28.6%, followed by Pulau Pinang, 28.2% and Selangor, 15.6%. The wastewater effluent that is being discharged from the industries contain a very complex mixture of molecule composition and color for each sample, which rise the degeneration problems and also influence the removal capability process. The issue on separation of the adsorbent from the treated influence and their application towards a continuous propagation system have been highlighted in this study. CNF's filter paper has its own challenge of reusability issues as another alternative way to decrease the high cost of operation and at the same time can lead to the environmentally friendly absorbent. Objective of the study are: first, to remove synthetic dyes from textile industry wastewater solution. Second, to elucidate the effect of the CNF's filter paper fouling and reusability of filter paper during the filtration process. Significance of study are: the study's significance are to emphasize how effective CNF filter paper made from NEOLAMARCKIA CADAMBA tree is during the filtration process of removing textile wastewater solution. The implementation of a closed-flow filtration system has been designed for this study based on the direct filtration concept. The use of nanocellulose as the environmentally friendly raw material for filter paper. The use of real textile industrial wastewater solution sample are able to evaluate the impact or effect of the sample on the filter paper performance. For the methodology part, my research planning through FYP1 and FYP2 is: for step 1, identify the objective and scope of the research. For step 2, find a journal to read for the literature review. For step 3, preparing research planning and methodology. Step 4 are doing a site visit to the industrial location to take a sample wastewater solution. Step 5 will be material and equipment preparation before the experiment start. Step 6 will be sampling and analyzing process, which is testing the wastewater solution parameter. Step 7 are about result and discussion. Last but not least, step 8, which are conclusion and finish the final year project. For the experimental setup analysis, closed-flow filtration system will be used throughout the study. Closed-flow filtration, also known as tangential flow filtration, separates particles in solution by placing the solution along the surface of a membrane. Liquid pass through the membrane due to the pressure differential across the membrane. Closed-flow systems are configured to allow for the recirculation of material along the membrane surface. In this way, large components are retained and smaller components are collected in the pass liquid. The system or reactor is eventually used and known as a photocatalytic membrane reactor. However, in this study, the system is known as a closed-flow filtration system due to its simple and more straightforward tasks which will be done for the application of CNF filter paper in the adsorption process. There is 3 analyses which be undergone by the industrial wastewater sample after processing via closed-flow filtration system. The analytical method which be involved are the normalized flow analysis, declaration efficiency, pH, BOD, COD and stability. Normalized flux value of the membrane analysis are function to investigate the CNF filter paper fouling behavior during the reaction in the closed flow filtration system. The value will be determined by plotting graph of normalized flux against operating time. For decoloration efficiency analysis, wastewater solution will be collected from the tank of the closed flow filtration system and measured by using a double beam of UV vis spectrophotometer DR6000, a maximum wavelength of 465 nanometer. For pH, BOD, COD and turbidity analysis, the wastewater sample solution will be analyzed under parameter of pH, BOD, COD and turbidity, which will follow the guideline from standard method. That's all from me. Thank you very much.